All right, welcome back to Learning with Merit. Today we're going to talk about while loops and two-dimensional lists. So first things first, we're going to look at a 2D list here. So I have a 2D list that I've written, and you can think of a 2D list as one of two things. It is a list of lists, or it is a list inside. It's a list with lists inside of it, right? Or we call that a nested list. Now the tricky thing about two-dimensional lists is that we have two indexes each time. And the reason for that is the outer list, the list that contains all the other lists, has the regular indexes, like 0, 1, 2, and 3. And so that this first list is 0, this second list is 1, 2, 3, right? Well, in each list inside has its own set of indexes. So you see how that gets repeated here. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So each of these lists has an index of their own. So we need two numbers every time we are going to do something with a two-dimensional list. Now one thing we may do is this is actually kind of hard to read and see. And so what we will usually do is simplify two-dimensional lists by making them in a matrix, or you could say like a grid. So this is the same two-dimensional list, but I've written it as a grid pattern. And now what we can do is we can say that it's made of rows and columns. So on the outside here, I've got the rows. So each row, 0, 1, 2, 3. And then we have columns, okay, up and down here, 0, 1, 2, 3. And this will make it really easy for us to actually go through and do things with this. So I'm going to show you real quick how to access. So if we want to access something from this, if I want to access the number 1, I need two values. The row index, which is 0, and the column index, which in this case is also 0. So this accesses the number 1. So I'll say number 1 like that. Now if I print it out, we should see the number 1 pop up, and it does. So let's change this. Maybe I want to look at 2, 0. 2, 0, so 2 rows down at the first column here, number 9. So let me clear this and hit run. Oops, clear it again, or again. It's not wanting to show up. Let's try it one more time. There we go, finally got it. All right, number 9. So let's see if we can get the number 16. The number 16 is at row 3 and column 3. So I'll say row 3, I'll say column 3, I'll hit run like that and get the number 16. So that's pretty simple for accessing the list. And what you need is you need the first index, which is the row, and the second index, which is the column in that row that we're looking for. So two indexes every time for two-dimensional lists. That's access. Now let's talk about changing something, right? If we want to change something in a two-dimensional list. Well, if we're going to change it, it's the same way that we change something in a one-dimensional list, except we need both indexes to define the thing we want to change. So I want to change the first element, this right here, 0, 0, the number 1, to the word changed. Then I give the two indexes after the list, and I say equals changed. And then I can print the list. I can say print list 2D, and I can see that it got changed. Whoops. Then I can see that it got changed. So you see, instead of the number 1, now we see changed 2, 3, 4, like that. So if I wanted to change something else, obviously, I just change the row and column indexes here. Now let's say that we want to get the length. Length is going to be a little bit different this time. So, as per usual, the last time we used length, we could just say length of the list. And this returns the length of list 2D. In this case, it's specifically the number of rows. So there's 1, 2, 3, 4 rows. The last index is 3, but there are 4 rows. But what if I wanted to get all of the columns in each of those rows? Well, then that becomes a little bit different. In order to actually get the number of columns, let me get rid of this here. In order to get the number of columns, then what I need to do is I need to tell it what row I'm at. So I'll say length, I'll call that function, then there'll be parentheses. Inside I'm going to say, all right, in list 2D at this given row. And so instead of row, I'm actually going to give a number this time. So row 0, there are 4 things in row 0. Row 1, there also happen to be 4 things in row 1. I made it real simple. I just did a 4x4 grid, but it may be different sometimes. We'll also, later, we're going to use the variable row. So we're going to define a variable called row, and we will use that to help us find out how many rows that there are. And then, or specifically what row that we are at. And then when we call this length of the given row, we figure out that's the number of columns, right? The number of columns in that particular row. Okay, returns the length of each row or the number of columns. So that can be kind of confusing because we're going to do a little bit different this time. But we're still using the length function. All right, so let's set up a loop now. Let's actually set up a loop. So we are going to have to use a nested loop. Oop. Got a little pop-up there on one of my files. So we need, anytime we create a while loop, we have to create a variable. And we're going to create 2. We're actually going to create a nested while loop because we need nested while loop. Because we need 2 loops. One to go through the rows and one to go through the columns. So we're going to use row instead of index this time because now we have 2 indexes we're working with. So let's distinguish between the 2. So we're going to say row equals 0, and this is our starting point. Our starting index in Python is 0, and that also happens to be the first index, or the first row is at index 0. Then we need our stopping point. So our stopping point, we are going to say, looks like this. While row is less than something, in this specific instance, the last index of the list is what we want row to be. And then we need our step. You always have to have a step in order to keep it going up. If you don't, you end up having an infinite loop, and we don't want one of those. And there's our step. And usually it's going to be one, either up or down, determining the plus or the minus. So there's our while loop to loop through the rows. And it's very generic right now. I'm missing some things, obviously, that we're going to add later when we determine whether we're going up or we're going down or what we're doing, right? Now we're going to create another while loop inside of this. So for each row, there are a certain number of columns. So let's create a while loop to do that. We need a variable, of course, to start. The variable we're going to use is col. Now you could also use R or C. You could use R and C if you wanted to. That's another way that people do it, but I wanted to make it clear with row and column. So we're using that. We're going to start at 0 typically, if we like to go forward through things. And so we're using col instead of index this time so that we can distinguish between the 2. We're going to start at 0 typically. And then, where do we want to stop? Well, we got the same thing here. Fix my indentation there. While column is less than something. In this case, the last index of the row if we're going forward. And we'll show you that in just a minute. Again, I'm leaving it blank because we're going to do forward and backward. And then we need our do stuff part. So here inside of this is where we want stuff to happen. So we'll call that do stuff here. And then we need our step for our column. So if we put this all together, all right, you'll notice I've also included where you need to indent and then where you need to unindent so that you can keep track of everything. So basically we have 2 while loops. We have an outer while loop, this is our row while loop, that goes through the rows. Then we have an inner while loop that goes through each column in each row. Right. And then we have our do stuff spot where we're going to do things like print out stuff or we're going to change something or do something like that. So this is your basic format for writing a nested while loop that will loop through a 2-dimensional list. So now we're going to work with looping forward through a 2-dimensional list. So we want to go forward, and this is the most common way that we are going to write this. And so we want to make something that's going to work for pretty much any list. Because again, we could go through and we could count, but that would be, tedious, especially with very big lists. And so what we have here is first we're going to figure out how do we go through the rows. Well, we want to start at 0. That's the beginning of our two-dimensional list. Start at 0. And we want to end, okay, we want to end at the last index of list 2D. So this is really the last row. So row at the index 3. So what I'm going to say is while row is less than what? Well, it's sort of like whenever we think about, and I've heard this from students before, it's like, why do I need to learn all this math when I can have a calculator do it for me? Now, I'm not advocating that you say that in a math class, but I do think it's a good idea for programming. All right? We want the computer to do it for us. So we're going to tell it to rather than do all the work ourselves. So we're going to say length in this case, and we're going to get the length of something to figure out what's the last index. Well, the length of what? The list. So in this case, we give it the name, length of list 2D. Now, normally I would say that the last index is always one less than the length of the list, and this is still true. The reason why I'm not doing -1 here is because I'm using a less than symbol. So row will go all the way up to the number right before the length of the list, and that's exactly where we want to be, -1, right? You could also say less than or equal to, and then you would need to use the -1, but this seems kind of unnecessary since you're writing more. So we're going to get rid of that. Now, it changes a little bit when we come down here to column. So that allows us to loop through the rows. Changes a little bit when we come down here to column. Instead of looping through the length of the list, I want to loop through the length of the row that I'm at. So what I do is I say length. I give it the list because the rows are in the list. And then I need to give it the row. Well, I need a variable to represent row because row is going to change every time. So I use the row variable that I created already. So this time I said the length of list 2D and the row that I'm at. And then this allows me to loop through each column in each row. Then for our steps, both of them are going to be 1. And then the only thing that might change, and we'll change this later if we're going down, is we would change the plus to minus. Right? Now for the do stuff part. If I want to print the indexes, this is pretty simple. I say print, use the variable row, then a comma, the variable column, then a comma, and then just for formatting's sake, I'm going to say end equals, just like that. Now there's one more thing I'm going to add, and again, it's just for formatting the output. I'm going to add a print statement right here with nothing in it, and that way it adds a new line. So what will happen is it will print the row and the column, and then a little line character so we can see that it's separated. And then it will print a new line once we get through all of the columns in a given row. And it'll make a nice grid pattern like we see up here with the indexes. And I suggest you do this because it'll make it easier for you to read too. So let me save that real quick. We'll hit play and see what we get. Oh, it's going to throw an error because I've got an extra period somewhere. All right, I fixed the period. Here we go. Oh, it's got an issue with it again because I didn't fix the period. There we go. All right. So now we have the indexes. So it goes 0, 0 all the way to 3, 3, and you can see it in a nice matrix or grid pattern, whichever way you prefer to say it. So that's the indexes. What if I want to do the elements here? Elements. So this is only a little bit different. This time what I'm going to do is I'm going to say, well, in list 2D, I want you to print out the thing at the row that I'm at, and then at the column that I'm at. So you got to give it two values, the row and the column. And if you do that, it should print out each element for the entire list going forward in that nice format that I just made. So here we go. And look at that right there. So it prints out all of the actual numbers just like I have up here. Okay. So now we're going to talk about looping backward through a two-dimensional list. So I want to loop backward through both the rows and the columns. Now I can do those individually. Okay? I could loop through the rows backwards, but the columns forward. I could loop through the columns backward, but the rows forward. Okay, so this is all interchangeable. I'm just going to show you how to do all of it. Okay, so here we've got row equals. Well, I want to start at the last row. And again, we want the computer to figure this out for us. So what I'm going to say is, since I know the last row, or last index, is always one less than the length of the list, then what I can say is length of list 2D, and then I need to subtract 1 so that I am at the last index. Then, instead of saying row is less than, I want row to be greater than, since I'm going to be counting down. I also want to say equals so that I actually get to the last index. In this case, the last index we're trying to get to is 0, or the beginning of the list, or the first row. These are all the same thing. So I say 0 there. Now for column, we're basically going to do the same thing. I want to start at the end of the row. So I say length. All right. Then I give it the list that I'm in. And then I want it to find the row that I'm at. And then because this would give me a number one more than the last index, I need to subtract 1. Same rule applies. So I'm subtracting 1 to get the last index of the row. Then I want to be less than, since I'm going down, or equal to, since I want to include my very last value. In this case, it is 0. We're going to the beginning of the row, which will always be 0. Then if we're going to print the elements, we do just what we did last time. No change there. Now, for our step, since column is going down, we need to do minus equals. And since row is going down, we need to do minus equals as well. So now what I'll do is I'll say that. And what we should see is basically this whole thing should be flipped. We should see 16 up here and 1 all the way down here. So if I hit run here, and we see 16 right there and 1 all the way down there. So I went all the way back. I went totally backwards. Okay. Backwards through the rows, backwards through the columns. If I want to print the indexes, then I just change this back to our row column thing. Row column call, like that. Save it, hit run. And now we see the indexes in reverse order. This is 3, 3, and this is 0, 0. And everything's in reverse order. Now remember that I mentioned you can do these interchangeably. So you could go backwards through the columns but still be going forward through the rows. Or you could do it vice versa. You could be going forward through the rows but backward through the columns. They're independent of each other. All right, now we're going to do something a little bit different. So we're going, instead of just printing stuff out like we've been doing in the past, this time we're going to use some conditionals. And these are going to allow us to change different things about what we're doing. So here I have simplified, I've taken out most of the notes so that we have plenty to look at. We have our row while loop that allows us to go through the rows, and then we have our column while loop that allows us to go through the columns. And you'll notice, hopefully, that this is going forward. So I'm going forward through the rows, I'm going forward through the columns. Now let's say I wanted to use a conditional to check the elements. Now what this means is that I want to check if there's a certain value at a particular element. So here's what we're going to do. I'm going to show you a list, a rather large list that I have written. And this is just one example of something we might use. So I'm going to stick this list up here because it's big. All right, there we go. You see this over here? That's a big list. All right, it's not something you want to have to do by yourself. But here's what we're going to do. We're going to write some code that'll go through this entire list for us, and we're going to check if there is a 1 there. And if there is a 1 there, we're going to add it to the count because I do not want to have to go through this thing and try to count all of those 1s by hand. All right, there's so much easier way. Let's write a while loop to do it. So here's all we have to do. We already have something to loop through the rows. we already have something to loop through the columns. Now we just need to tell it what to do. So we're going to write a conditional. We're going to say if, and then if what? Well, the element that we were at. So we use the element. We say, all right, in list 2D, I want the thing at the row that we're at the column that we are at. And I want you to check and see if it is equal. So I'm going to say equals equals the number 1. If it equals the number 1, here's what we're going to do. We're going to increase a counting variable. So I need to come up here and I need to create another variable to keep track of my count. And I'm going to call it count ones. We start our counts at 0. So then if it's a 1, we're going to increase that count ones by 1. So we just say count ones plus equals 1, like that. And then all the way at the end, all the way down here, outside of all of my while loops, I'm going to tell it to print that count. That way, it counts it for me, and I don't have to go through and see how many ones are in here. So let's see what it prints out for us. Make sure I save and run here. There are apparently 82 ones in that. Now, I would hate to have had to go through all of that and do that. That would just be so horrible. So once again, that is using a conditional to check the elements. So we're able to check and see if there's a 1 there. What if we want to know how many zeros there are? Well, you just change that to zeros. You change your variable to count zeros or something like that. And you add 1 to it every time, and it'll tell you how many zeros are there. Okay, pretty simple concept. Now let's say, what if we instead of just checking if there's a 1 and counting it, what if we wanted to change something? We could do that too. So I'm going to get rid of count ones. And instead of all of that, we're going to change something every time it's a 1. So how about every time it's a 1, let's make it an X. So let's say, okay, if it's a 1, list 2D, row, column, equals an X now. Now, that'll make it a little bit easier for me to see. And then we can add in an else. So if it's not a 1, meaning it's literally anything else, what do I want to do? I'm going to say list 2D, the thing at that row, that column, okay. And we're going to say we want that to just be a dash. Whoops. We want that to just be a dash. And so what will happen is it'll turn all the zeros, everything that's not a 1, into a dash. It'll turn everything that is a 1 into an X, and it'll make it a lot easier for me to see. And then all I need to do is come down here and tell it to print it out. Print list 2D, row, column, add my little end thing, end equals. I'm just going to add a space this time. And then down here, right before row, I add a print statement, so it makes it look like a nice, pretty matrix. So here, all I've done was really add this to something that would normally be printing it out, and this is going to change the values. So now, all right, let's see. It doesn't like my indent here. So let's see if I've got my indent off. All right, let's try that again. So I didn't have to change anything. And we hit run. Oh, and you'll see this now. So let me drag this out so you can see it all. And if we scroll down, everywhere you see an X is where there was a 1 in that list, and it printed out that whole thing for me. So now I can see where every single 1 was at in that list very easily and without a lot of effort. And that's pretty cool. So that was using a conditional to change the values. So we use this conditional right here. Okay, don't need that period. we use this conditional right here to check if each element was a 1. If it was a 1, we changed it into an X. And then if it wasn't, we changed it into a dash. And then that allowed us to visualize what it looked like. So I'll show that to you again one more time. It keeps giving me a little bit of an error here because it's not liking me tonight. We'll try it again. Man, it's just not very happy. Well, we can do this another way here. See if it'll give me a terminal. I won't let me do that. Anyway, we'll just go ahead and be done there. It keeps wanting to throw an error. There isn't an error here. List 2D is clearly defined. Let's try saving it one more time. We'll throw... There we're in. Alright, so sometimes computers don't like to work with you very well. But anyway, there's the output one last time. And you can see it. It changed all the ones into X's. Okay? And this is why... This is the last thing I'm going to leave you with. This is why, right here, you want to learn to get the computer to do it for you. I doubt you wanted to sit there and count all of those. That would have been horrible. It'd been really hard to keep track of as you're zooming, you're scrolling down. It's a lot easier to say, hey, computer, count for me. All right, so use these tools. All right, and thank you for watching.